All right, so let's look at this function. So the question is here, I have two functions, ti plus tj, and 1 over that. Which one is an autocorrelation function? So the autocorrelation function is a non-negative definite function. That means if you put I equal to 1 through n and j equal to 1 through n and create a matrix whose ijth entry is rij, either this or this, then if it is an autocorrelation function, this should be a non-negative definite matrix. That means all the eigenvalues are positive and the determinant is also positive. So if you find a case where that is not true, then that function is not an autocorrelation matrix. So let's check the first one. I'm just going to try a 2 by 2 case and let's see what happens. So let's try rij equal to ti plus tj, and I'm going to do a 2 by 2 matrix. So one I goes from 1 to j goes from 1 to, so this will be 2 1 t 2 t1. This will be t1 plus t2. This is t1 plus t2, 2 t2. So I'm going to do the determinant of this. That is 4 t1 t2 minus t1 plus t2 the whole squared. So, but that's minus of t1 minus t2 the whole squared, and that's clearly negative, the determinant. So we can say that ti plus tj. So obviously this is not positive definite, even just for 2 by 2. And so it's over. ti plus tj is not an autocorrelation function. Let's say the original problem is for ti and tj positive. So the question is this is not an autocorrelation function. All right, so the question is, what about the other function? In other words, if rij is 1 over ti plus tj, what about this one? So here, how do you do this? I mean, again, conceptually we need to form an n by n matrix for arbitrary n and show that that's a non-negative definite matrix. So I'm going to give one idea, which I've seen somewhere. So let's look at this function. This vector rather. So this is an n by 1 vector. Let me take all the lambdas to be positive. So they're all dying exponentials. So I'm going to do a y star. So that will be, this is n by 1. So y star will be n by n. And I'm going to integrate from 0 to infinity. So if I do that, the ijth entry will be e raised to minus lambda I plus lambda j t. When I integrate that entry, you'll get 1 over lambda I plus lambda j with a minus sign. On the numerator, you have lambda I plus lambda jt. When you put the integral 0 to infinity, top limit is 0, bottom limit is 1. So you get lambda I plus lambda j. So this is an old result. So we have this property that any matrix with, so if I call this to be R, any mat or A rather, a matrix whose ijth entry is 1 over lambda I plus lambda j, where lambda i's are non-negative. This is a positive matrix because you can see here, this is A is positive, or clearly to see, another way to see it is you take any vector, arbitrary vector psi, and so A is this way. So if you do that, that will turn out to be psi star y, remember yt transpose psi. But y transpose psi is just a scalar. Maybe call it to be z of t. So this is simply integral 0 to t zt squared. So what we have shown is for any arbitrary n, remember this was y, so this was a, so for any arbitrary a, this is a non-negative matrix. So A is a non-negative definite matrix. Where so now you can see where I'm going. So if I create a covariance or a matrix with the ti plus tj, with all the ti comma tj positive, then this will be a non-negative definite matrix. So that means R of ti comma tj is 1 over ti plus tj is an autocorrelation function. An interesting observation. That's all. Thank you.